Alright guys, so this is an important video, so I'll be starting to show you like the understanding of the different type of registers. So you might think I into too much code in this video, but in the next videos or the upcoming videos, we're going deeper into how we will code different stuff so you can understand how to use these registers, right? So the first register I'm gonna go through is the port register. So port X. You'll understand what the X means in a bit when we get into the pick, but for now just know port X is the first one, and basically what this does, it reads the actual logic value of the pin. So it's good for like input pins, like if you have a switch. So for anything that gives a variation of voltage in digitally, either 1 or 0. So you could use this, so you could read this register to know what the pin has at the current time. So it's actually real time readings of the pin. Okay, so it returns the current state of the pin, which may be affected by external factors. So yes, that makes sense. So basically, port, you use it to read the value of the pin. That is basically what is most useful for. As I said, useful when reading an input pin, aka a switch. Alright, the second register is the trace register. And basically what this does, it configures the pin as either input or output pin. That's really all you have to understand. So for input, you set it to be a 1, and for output, you set it to be a 0. Output O, 0, output, and I input looks like a 1, so input. So trace is direction. Lat lat now. So what lat does, it is like port, but the difference between lat is that it stores this value forever. It literally doesn't change. So it's like somebody tell it to hold something, you literally just gonna be holding that forever. And this is good for output pins. Like if you wanna light a LED and such, you could just set it on and it will just stay on. Or you can set it off and it will just stay off regardless. So this is useful when writing to output pins like LED or any other external um, stuff that you connect to your pin. So lat is to store values. Okay? So you'd really read from the lat as the port because as I said lat, it just stores the previous value. It just stays, if it's a 1, it's just going to stay as a 1. So you won't be able to use it for real-time readings on the pin. So this is more useful for output pins because you wouldn't want the output to change constantly due to external factors. So you'll just write here lat and it will just stay. If you put it as a 1, it will just stay as a 1. If you put it as a 0, it will just stay as a 0 until you override it. The next register is the ANSL register, ANSL X. So what it does, it configures the pin as an analog pin or a digital pin. So analog meaning that the input, it could change, it changes continuously. So mostly you'll see this for analog to digital conversion because for ADC you have a variation of voltages coming in. So you'll want to configure the pin to allow these type of inputs. And the other one is digital, which if it's just either a 1 or a 0, depending on the voltage range. So if it's over 2.3 volts is a 1, if it under that is a 0. So it's fixed ranges. So you'll set that as a 1, sorry, a 0 to be a digital pin. And if you want it to be analog, you set it to be a 1. Right, these 1s and 0s may change depending on the type of pick you have, but just the understanding of it. As I said, is useful for ADC conversion. So summary, the port basically is what you have right now. The trace is what direction you're going. Ansel is if you're analog or digital. And the lat basically just holds the value, literally just holds a value until you override it. Okay, so those are the main registers. There are more, but for now we'll just work on understanding these because these are the most important. The other registers, their default value won't really affect you too much depending on your application. But for now, understanding these very important because they lay the backbone to all the other code. So I was saying something about X and X and X all the time. So I just go through what I mean by this X. So I'll just switch across to the manual. So this is the pick. This is our pick. So basically what the pick is broken down to is different ports. And the ports is made of normally 8 pins. So they go from 0 to 7. Yes, 0 to 7 is 8 pins. So you have port A, you have port B, port D, port C. So that is what A, B, C, D. So there are four ports. And each of those four ports they have approximately eight pins. So you'll be able to use, but not all the pins in the ports you'll be able to use to do certain stuff, because some of them they already have a special function. So like the MPLAB, these up here, the RB7 and the RB6, you wouldn't be able to use them to do normal stuff, but the other pins, you should be able to use it to do whatever you want it to do. So port A are normally written as RA or RB or RC, and then the numbers afterwards just tell it which pin number it is. So RA0 is the first pin in the port A register, RB1 is the second pin in the port B register, because remember going 0, 1. So 0 is the first, so 1 will be the second pin. So that's how the board or a pick is laid out in terms of ports, and each port is made up of X amount of pins. So some special pins you need to pay attention to is your VD and your VSS pin. So that is your power. So VDD is your positive 5 volts, and your VSS is your ground, and it also has it on this side also. You have your MPLAB pin. Normally that'll be connected to a positive 5 volts. So you want to enable it. So that is your MPLAB. And all the other pins are normal. So you have your port A, 1, 2, 3, 4, 5, and it starts and continues down. So it may not be all the time in one direction, all the time it might jump and skip. You just don't know what port you're in, and you'll be good. So if you want to use RE0, you open the pick and you find RE0, and that will be the first pin in the port E register. So that's how the pin is laid out. So when you go back to what I was explaining, when you use these ports and these tris and these lats, all those 5 registers are very important in terms of how you will program your pick to allow the pin to do what it wants to do. So for example, if I have RA0 here and I want RA0 to be simple, let's say I want it to be an input pin. An input pin, so we say a digital, because we had to specify. So if I want it to be an input pin, if I wanted to write what each would be, the ports, so it will be port A, because remember it's the port A register. So port don't really have anything in it because it's an input pin. So I don't really need the port for this. The next thing we'll need is the tris A, and I want that to be an input. So I'll set it to be a 1. We'll explain how exactly you set it when you go into the code, but for now just to understand what it does. So I'll set the pin to be an input. The second thing I need to do is set it to be a digital pin. So I'll set it to be a 0. Right? So I have the direction. I have basically digital, so input, a digital input. So the other ones, you have your lat. So remember, your lat is normally used for output pins. So remember, you're reading in these values from this pin. So normally what most people would do, they will clear the port. So when you program the pick, you will just clear the previous value of the port. You will start at clear. So basically for input pin, these are the 3 main ones I will need. So if you wanted, like we say on RB5, I wanted to put an output pin. The first thing I'll do, so is an output. So the first thing I'll set is my direction, so it'll be tris B, and I will set it to be an output, so that is 0. The second thing I want to do is set it to be a digital output. So direction, good. We know it's digital. The next thing we'll want to do is the port. So you want to just clear it. Just for good practice, just clear the port before you do anything. And then now if I want to actually control what the output of the pin is, I use my lat register. So it'll be lat B. And like we say, it's a LED. If I want to put on the LED, I set it to be a 1. And if I want to take off the LED, I set it to be a 0. Remember, the lat, it just holds that value forever and ever until you override it. Okay? So like basically how the registers work. So you have your pins, each pin is in a port. So you'll need to know the port letter and the location, and then from there now you have to know the application or what they use any pin to do, either output or input pin. And from those things you will know how to code your registers to program it to do what you want it to do. Okay, so that's a general summary of how the pick works. So let's jump back over to MPLAB or something. So something cool that you could practice is, instead of like to understand it. So let's say you have ports A here. So we know you have your 8 pins. So now maybe most you start 1, 2, 3 and you go across to the left. So this will be pin 1, 2, 3, 4. So let's say I want to set pin 3 to be 1. Instead of just doing it one by one, what I could do, I could copy an entire 8-bit value into the specific register that I want, whether it's the tris or the port or the lat or whatever it is. Okay, so you see this more when you start the code, but something you could think about is 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8-bit pick. So this is how the pick will see all the values. So if I wanted to just set the first pin on a particular register to be 1, I could just use this value. Or if I want to set the 8th one, I can do this. So you'll understand this more when you start the code, but something to keep in mind that you always have to, do it one by one. You can just do it for the whole thing. And actually it is better because it prevents overrides. So yes, so a pin might be on something that you didn't want it to be on, and because that pin doing something it's affecting another pin that you want to do something specific. So as a rule of thumb, you want to set all the other pins to be default and only work with the pin that you want. So you're kind of setting everything and then working what you want. So it kind of helps you with organization and neatness. So you're not run into too much problems. Okay? So far in any video there. So far we learned the 1, 2, 3, 4 main registers. Port, you want to read from the pin. Tris, direction, lat, hold this until digital or analog pin. So we learn how the pick function in terms of the different ports and the pins, and we went to the manual, and I showed you all this. You'll understand this more in future videos. So far in the code, you also know how to set up a list. You include your configs, and there's another part with the memory organization, which we will get to in another video. But you also remember the org 0x00, and then you go to main, and the org 0x05, and so forth. That's how you set up your code. So that'll be in previous videos. As I said, this video is not for code, but you'll get deeper into the code afterwards. So I'll show you how to light a LED. Alright, so later, and we'll talk. So remember, if you all want to sign up for the sessions that I do, the link will be in the description, so you have to go ahead and sign up. Otherwise, we'll talk any other one later.